Jai Hind everyone, I am Ankita Sharma. I work here in Ajay Kumar Garg Engineering College as an assistant professor in ECE department. So today we are going to cover our complex topic number 3 under the code BEC 502 of subject microprocessor and microcontroller. So the topic is instruction set of 8085, and in instruction set we will be covering two types, that is data transfer instructions and arithmetic instructions. So if we start from the instructions, so instruction, what is an instruction? Instruction generally is a type from which we can decide which type of function is to be performed in particular microprocessor. For example, in 808 microprocessor, what is happening inside the microprocessor, which function is there, are we doing data transfer, are we doing arithmetic instructions, logical instructions. So all these are decided by the instructions, and the entire group of instructions that a microprocessor support is the instruction set. And as we all know, 8085 microprocessor is an 8-bit device, and as it is an 8-bit device, so it can have total 256 opcodes. For example, 2 raised to power 8, it will be 256. So 256 opcodes are there, and all the instructions are of 8-bit here. The opcodes are of 8-bit, and opcodes are operation codes, and after the operation codes, and each opcode is of 8-bit, or we can say 1 byte. So the opcode is of 1 byte or 8 bits, and here we can use 246 combinations, and total 74 types of instructions are there. 74 types of instructions, and it represents 256 combinations here. So before going further for the instruction set, first we have to know what is the data formats and what is the instruction format in 8085 microprocessor. For that, we should be aware that instruction will be of two parts. First will be my opcode, and second one is the operand. Now opcode will always be there, which will be telling the function, which function or which task is to be performed. What is the operation of that particular code? That is why it is known as opcode, and opcode is of 1 byte only. And next, second part is my operand. So I can also write, this will be my opcode, there will be a comma here, and the second thing is operand. So for any instruction, these two things will be required, opcode and operand. Sometimes operand is not given directly, opcode is given. So that is some other type of instruction that we will be covering in the next video lecture. So opcode and operand. So the second part, where on which data the operation is to be performed. First thing is the operation is to be performed, it is opcode, and on which data, on which register the instruction, the operation is performed, it is my operand. Here in 8085 there are total 5 types of instructions. First is my data transfer, then it is my arithmetic operations, logical operations, branch operations, and machine control operations. Data transfer here signifies that when we have to transfer data from one place to another place, that data can be stored in some register, in some memory, or the data can directly be given in the instruction itself. So there are 3 types of instructions here in data transfer. First, the data transfer will be between 2 registers. Second, the data transfer will be between a register and a memory location. And third will be my immediate data which will be given. So in data transfer, basically, simply when I am transferring the data, that means I am just copying it. So it will not be deleted from the source. It will reach the destination. The second copy will be received at the destination. So we can say it is moving, but while moving it is not deleting from the source and reaching at the destination, but instead it will remain in the source as well, and it will have a copy at the destination as well. So it is, the source is not changed at all while the data transfer instructions. So these are few examples for the data transfer instructions. Move, MOV, move, when I have to move data from one place to another place, from source to index, and that is between 2 registers only. We will be covering these all instructions in details in next few slides. So move MVI, MVI means move immediately, when the data which is to be transferred is given directly. For example, I know I have to transfer 15. in some register. So 15 is given in the instruction itself. So that is why it is called as immediate instruction. Next is LDA and STA. These two instructions are used for the accumulators. As we all know, accumulator is a special register in the microprocessor which is used to store the logical and arithmetic operation data as well. So accumulator will be here in LDA and STA. LDAX and STAX is an indirect instruction where the data to be transferred is not given directly. We will discuss this later. So the data transfer here, how can the data transfer be done? The data can be transferred between two registers. Now the question is, how many registers are there? In microprocessor 8085, as we all know, there are 6 registers, B, C, D, E, H and L. But H and L can also be denoted by M, which is memory pointer, and accumulator as well. So there are many possibilities to transfer the data, that is B, C, D, E, H, L. I can use M as the memory pointer as well and the accumulator also. So these are the registers which will be used to transfer the data. One data byte means 8 bits. 1 byte means 8 bits of data. So one data byte is to be transferred to particular register or a memory location as well. Here memory location will be my M. Data between a memory location and a register also, and data can be transferred between input output device and the accumulator. For that we will be using some other instructions here, in and out, and also some other instructions. So in detail, as we have seen here, the opcode was move. So from move, how many different variations can be done, how many different methods are there to transfer while using the opcode move? Now we are going to see that. So the operation code is move, which is MOV. These 3 are the operands, probable operands which we can use. RD here is the destination register, RS is my source register. So the data will always be travel from this side to this side. So first on the left side the destination will be given, and on the right side the source will be given always. So this is my source, this is my destination. So data transfer will be from RD, from RS to RD. I can write it like this also, move B, comma A. So the data transfer is happening between two registers only. Here what will happen? The contents of accumulator A will be copied to register B. One thing is to be noted here, we are copying the contents, we are not deleting the contents from accumulator and then copying it to B register. No. For example, I have to copy number 40H. This is an hexadecimal number. So accumulator is having 40. This 40 will be copied to register B, and after this instruction is done, what will happen? Accumulator was having 40H, but after this instruction what will happen? Register B will also have 40. So these two, A and B, will both have 40H individually. Next is RM, RS and M. M is the memory pointer and S is the source register. So it is like M, comma B. I can take accumulator as well here. So many different registers can be taken here. Next is between memory pointer to destination register. I can reverse here. M is fixed. I cannot shift M anywhere because M is the memory pointer, and what is M doing here? M is just pointing the contents of the HL pair register. As we all know, HL pair are directly located with the help of memory pointer, which is M. It is of 8-bit. M is 8-bit and destination register, suppose it is B register. So what will happen? The contents of HL pair, which will be of 16-bit, they will be pointing to some other address, and that particular address will have some 8-bit data, and that data will be copied to register B here. So these 3 are the probabilities, and these 3 transfers can be done while using opcode move. Next is MVI. MVI is generally translating that move immediately. When the thing is transferred immediately, that means the data which I need to be translated or transferred is given itself in the opcode also. So this is my opcode, this is my operand. I can also take an example. It will be MVI B comma any 8-bit data. This data will be of 8 bit, so I can take 41H. What will happen now? 41 will be copied to register B. So when the data is directly given in the instruction itself, it is immediate instruction. Next is now LDA. Here, as we all know, address bus is of 16-bit, so that is why the memory location always will be pointed 16-bit address. So 16-bit, for example, I can take 250H, 2500H, 2500H. So LDA 2500H. What does LDA signifies? LDA means load accumulator directly. What I am going to do, I will be loading the accumulator with the given contents, but accumulator is of 8-bit and the given content is of 16-bit. So can we copy 16-bit data or 16-bit address to some 8-bit storage? No, it is not possible. Then what will happen? This 16-bit address will be having a data. That data is of 8-bit and this 8-bit will be copied to the accumulator. So that is why it is LDA. This is a direct instruction, as the data to be transferred is given directly in the opcode. Next is STA. What is happening here? Store accumulator. The contents of the accumulator will be stored to some memory location which is given here. For example, 2001H is there. So accumulator's content will be copied to 2001 address. LDAX. Now, there is a difference between LDA and LDAX. The only difference is that in LDA, the 16-bit address is directly given in the instruction itself. As we can see here, it was LDA 2500H. But LDAX, here X is pointing the extended pair. As we all know, B, C and DE are two registers pair which we will use here, but H and L are also a register pair. But in instructions, HL register pairs which are used as memory pointer cannot be used to transfer the contents from accumulator or to accumulator. So we can use only two register pairs, that is B and C and DE register pair. So what will happen? The content of BC register pair, which will be of 16 bits, it will point to some 8-bit data and that 8-bit data will be loaded to the accumulator. Similarly, STAX, accumulator's contents will be stored to the memory address which is pointed by the register pair, given register pair. For example, it is STAD and D and E register pair is having value 2100H. So at this 2100H, there will be the contents of accumulator, the 8-bit contents. Next is my LXI. LXI means load given register pair immediately. This register pair will immediately be loaded by the given 16-bit data. So the register pair and the data will both be given in the instruction itself. So we can take an example here. It will be LXI H, 4000H. What will happen here? 0 is the lower byte, 40 is the upper byte. So 00 will be transferred to register L and 40 will be transferred and copied to register H. Next is LHLD, load HL pair directly. So HL pair will directly be loaded by the given 16-bit address. Lower part will go in the L register, higher part or upper part will go in the H register. Next is SHLD, store HL pair directly. Store HL pair directly matlab HL pair contents will be copied to the given address. For example, the address is 2500H. Now what will happen? L's content will go to 2500H and H register's contents will go to 2501H. There will be an increment in the address. Next is exchange. Now there is a confusion between exchange and XTHL. This and this. So we have to look for the opcode. It is XCHG, which clearly signifies we have to exchange. Now the operand is not given. This opcode is enough to explain the instruction. What will going to happen? the contents of H register will be exchanged with the content of register D. This is fixed. We cannot take any other register pair except HL and DE. This is fixed. So when the exchange instruction is there, we have to transfer, or we have to exchange, sorry, not transfer, we have to exchange the contents of HL register pair with the contents of DE register pair. How this is going to happen? H's content will go to E register, E's content will go to L register. Similarly, H register's content will go to D register and D's contents will go to H register. So these two register pairs will exchange their contents with each other. Next is SPHL. Now here SP generally defines the stack pointer. As we all know, stack pointer in 8085 is of 16 bit and HL register pair is also of 16 bits. Now what going to happen? This instruction will load the contents of HL pair with the stack pointer. So the content of HL pair is given and this HL pair's content will load in the stack pointer. For example, H is having 25, L is having 00. So after SPHL, the stack pointer will become now 2500H. For example, one more example, suppose H's contents was 40 and L's contents was 0AH, hexadecimal number. After SPHL, what was happening? So the stack pointer's contents will become 400AH because HL pair was pointing to 400AH. That is why. So this instruction loads the contents of HL pair into the stack pointer. Now the stack pointer will be either 2500 or 400A if the contents are these. Next is XTHL. Now XTHL here denotes we have to exchange the contents. Which contents we am going to exchange? I am going to exchange the contents with the stack pointer here. So stack pointer is having some data that is going to copy in register L, and if I increment in H register or stack point register, stack pointer will be having an increment and it will become SP plus 1. That stack pointer plus 1 address will be having some data, it will be copied in register H. Let's see this with an example. Here stack pointer is having 2700, H is having 30, L is having 40. At 2700 in stack pointer, there was some address, there was some data which is 50H, and after one increment it is 60H. I have applied XTHL, exchange HL pair with stack pointer. Now what will happen? This 50 here will be in L and this 60 will become the content of H. But next thing, I have to exchange the contents. Now what will happen? Previous contents of H and L now be the part of stack pointer here. 40 is at 2700 because L register was pointing 40H and 270 will be having 30H because H register was pointing 30H. That is why. So after applying XTHL, exchange HL pair with stack pointer, what will happen? L's content will be exchanged with stack pointer and H register's contents will be exchanged with stack pointer plus 1. This is also very important instruction. Next is PCHL. PC here denotes the program counter. Program counter is also of 16 bit and HL register pair is also of 16 bit. What will happen here? The contents of register pair HL will be copied in the program counter. Here we are not exchanging anything. We are just copying it. HL pair will be copied in the PC register pair. Simple. Suppose HL was having value 2500H. After this PCHL, what will happen? Program counter register will have the value 2500H. And what program counter do? Program counter generally stores the address of next instruction on which the microprocessor have to work. So generally the next instruction will be at 2500H if the contents of program counter are 2500H. Next is push and pop. So as we all know, push and pop, these two instructions are for the stack pointer, because stack pointer can move either push or pop. These two functions are there for our stack pointer. What will happen in push? Push is given with a register pair. I can use push B or push D. Now push B, as it is given, it is a register pair. So B is a register pair of C. So B and C are register pair, D and E are register pair here, and HL, L are also register pair. So what is happening here? The contents of that register pair will be copied onto the stack, and the stack pointer will decrement here. As we can see, 42 is given for H, F2 is given for L register. 2097 here is the contents of stack pointer. So what will happen? This F2 will go to 2097, then there will be plus 1 here, and 42 will go to 2098 here. So this is pop register. What will here happen? Similarly, what I have copied in push, it will be pop out. F2 will be pop to L register, and 42 will be copied to H register here. Next is in and out instruction. In instruction is generally when the input output ports contents are copied into the accumulator. There are 8-bit port address given here in input output port. Both ports address is of 8 bits. So port address, suppose it is given 80H. So 80's content will be copied to the accumulator when I need input, when this copied into the accumulator, because it is an into the accumulator, and out means accumulator's contents will be copied to the port address given here. For example, it was given out 50H. What will happen? Accumulator's content will copy to 50H. Next is my arithmetic instruction, which is also very important instruction. It is having 4 types: addition, subtraction, increment and decrement. Addition is of 8-bit and the sum is stored in the accumulator. And let's see some examples. Add R means I have to add between two registers. Here it is given add B means I have to do A plus B and the result is stored in accumulator. Add M means memory contents will be added with the accumulator. ADC means add with carry. So what I am going to do, accumulator's content will be A plus that particular register plus carry, and in memory accumulator's contents will be accumulator plus memory plus carry. So these are addition instructions. ADI is my 8-bit data given here. For example, it is given ADI 07H. What will happen? Accumulator's contents will be added with the given data and the result will be stored in the accumulator itself. In the arithmetic instructions, all the result is stored in the accumulator. ACI means data plus accumulator plus carry. These 3 things are added and the result is stored in the accumulator itself. Next is DAD. DAD is here is HL pair is added with the DE register pair and the contents here given and the result will be stored in the HL pair only, and this is fixed for only DE register pair. The 16-bit contents here will be added to the DE register pair. In subtraction, similarly, it is also between accumulator and some other register. So A minus R and the result is stored in the accumulator. This will be A minus M, contents or result is stored in the accumulator. SBB is subtract with borrow. Now what will happen? Accumulator will be subtracting the register with the borrow also. Here accumulator will be subtracting memory and the borrow also. These 2 things will be subtracted. Next is subtract immediately with 8-bit data, subtract immediately with borrow and 8-bit data both, just like the addition. Here what we are going to do? Here we are just adding it, and in subtraction we are just subtracting it. Next is increment and decrement. Increment is also of +1, and in increment in pair is also of 1 bit. Only one increment is there, and decrement is also of 1. For example, in one instruction, in one register increment, memory increment, here X is for pair. When I have to increment in register pair, it is given I and X. X is for extended pair. Similarly, in decrement it is DCX, that is decrement in whole pair, not only single register. So these are the references. Thank you.